What is going on, YouTube? I know it's been some time, maybe like 3 weeks since I've posted, and I know I made a commitment to post every Sunday, and I do feel kind of badly that I kind of fell off. I've been going through different work stresses, different stresses in my life. I haven't been able to focus on the things I really want to focus on, and I'm hoping to get it back. I think it's important to stick to your schedule, and this is me. So, today let's talk about API traffic management and important considerations when talking about rate limits. So, let's get into it. So, to introduce this, when an API becomes available to the public, there can be an influx of users and services. Anyone can use it as much as they want, potentially preventing other legitimate users. API providers have limited resources per unit of time provisioned, and they want their services to be fairly available to all their customers. Too many requests can overwhelm API gateways. Therefore, API owners enforce a limit on the number of requests or the amount of client data from clients. This constraint on the number of requests or usage is carried out by a component called the API rate limiter. The API rate limiter throttles clients' requests that exceed the predefined limit in a unit of time instead of disconnecting them. Throttling refers to controlling the flow by discarding some of the requests. It can be considered a security feature to prevent bot and DOS attacks that can overwhelm a server by sending a burst of requests. Overall, rate limiting provides a protective layer when a large number of requests per unit of time, a spike, or thundering herds is directed at an API. These days, businesses earn money when more people use their APIs. Actually, businesses earn something per API call. Aren't we making a business lose money by using a rate limiter to limit the number of requests? The purpose of the rate limiter is not to throttle requests without a reason, but to average out the spikes to avoid possible service overload and keep the traffic within provisioned computational resources. Due to the rate limiter, every client is given a fair share of a service quota. So let's talk about the responsibilities of a rate limiter. In addition to a security feature, a rate limiter should also provide the following capabilities to manage API traffic. So firstly, we have a consumption quota, which specifies the maximum number of API calls to the backend that a certain application is permitted to make in a particular time frame. API calls that go beyond the allocated quota may be throttled. There's also spike arrest, which recognizes and prevents an unexpected rise in API traffic. It also protects the backend systems and reduces performance lags and downtime. There's also usage throttling. This slows down an enormous number of API calls from a specified user within a specified time frame. Usage throttling improves the overall performance, leading to a reduced impact, especially during peak hours. There's also traffic prioritizations, prioritizes incoming requests depending on their criticality, which ensures a balanced and stable API service. For example, an API can be used by both freemium and premium users. Both types of users should have different amounts of API usage quotas. So let's describe the working of a rate limiter. Whenever a rate limiter receives an API request, it looks for the client's information in the database or cache, including the number of requests allowed to the users. If the count of the requests is already made is less than the maximum number of requests allowed, the current request is forwarded to the servers and the count is incremented. So, for example, as shown in the following illustration, a client with the ID 101 is making a request for a service. The rate limiter allows this request because the count for the incoming request is 3, which is less than the maximum number of allowed requests per unit of time, which is 5. So as you can see, our client with the ID 101 is calling a web server, and then that web server hits our rate limiter, and our count for that ID is 3, which is less than 5. So we increment it and we allow our request to go through. And then our web server hits our other backend services, right? And we get a response. And then our client gets the response, right? So if each request goes out of the rate limiter, then that means that the rate limiter is on the critical path and can add latency to the user. How can we manage this problem? For a rate limiter to avoid causing latency, we should design it in a way to utilize a high-speed cache and do some work offline, not on the client's critical path. So where do we place a rate limiter? A rate limiter can be placed in 3 different locations. So firstly, on the client side, The simplest way is to put a rate limiter on the client side. However, this way, the rate limiter becomes vulnerable to malicious activity, and the service provider configuration can't be easily applied. Additionally, clients may intervene in the rate limiting value and send as many requests as they want, eradicating its actual goal. A rate limiter can also be placed on the server side within the API server. This way, the same server that provides API services can also handle rate limiting complexities. And you can also place it as middleware. Another approach is to place a rate limiter is to isolate it from front-end and back-end servers and place it as a middleware. This way, the rate limiting services are isolated from the rest of the activities taking place in the system. We can conclude that placing a rate limiter on either the server side or the middleware is suitable. Moving forward, our discussion will be applicable to any of these two approaches because we'll limit our discussion to the rate limiter itself rather than where to place it. So let's talk about characteristics of rate limiting. When an API becomes popular and the API owners see a surge of traffic that could affect the availability of the application, they may start exploring rate limiting mechanisms. The primary goal of the rate limiter is to protect the infrastructure and product. While implementing a rate limiting system, we should provide the following characteristics that make consumers' lives easier. So firstly, we want to return the appropriate HTTP status code. So whenever a request is throttled, the system should return a HTTP 429 status code showing that the number of incoming requests has reached a predefined limit for a given amount of time. It's also standard practice to let the developers know when they can try the request again by setting the retry after header. Developers can use this header to retry the request, X rate limit resource. This header indicates the resource name for which the rate limit status is returned. There's also rate limit custom response HTTP headers. Apart from the status code, we should include some other custom response headers about the rate limit. These headers help developers when they need to retry their requests. These headers include the following. So we have X rate limit. This header represents the maximum rate limit for calling a particular endpoint within a specified amount of time. There's also X rate limit remaining. This header represents the number of remaining requests available to developers in the current time frame. And then there's X rate limit reset. This header indicates the time at which the time window is reset in UTC epoch seconds. As shown below, the output X rate limit shows the number of requests a user can make to the server. The X rate limit remaining is the number of requests that we can make in an hour. This value is decremented as we make requests. So as you can see, X rate limit is 60 here. And this quota is reset after X rate limit reset, which represents the timestamp in the future. The value of X rate limit resource is core. This represents the core GitHub resource, right? So we have an X rate limit reset, which represents a timestamp in the future. And we also have X rate limit remaining. So there's rate limit status API. If there are different APIs for different endpoints, there should be a way for clients to query the limit status of various API endpoints. There's also documenting rate limits. Documenting rate limit values can help users make the right architectural choices. This will allow them to learn about the APIs before getting trapped in the rate limit errors. Let's talk about rate limiting best practices. Appropriate rate limiting algorithms. One good practice is that the server should pick rate limiting algorithms based on the traffic pattern that it supports. There are various rate limiting algorithms that we can choose. For example, token bucket, leaking bucket, fixed window counter, sliding window log, sliding window counter. There's also rate limiting threshold. A rate limit threshold should be chosen carefully depending on the number of users of an API and the average behavior of a typical customer. For example, for social media applications, the number of users can be several million, so the rate limit value should be kept relatively higher. These thresholds might need to update over time as workload patterns change. And we should also offer documentation for developers. We should offer a clear guidance to developers about the rate limit thresholds and how they can request additional quotas so that they can continue their work without any hurdles. There's also smooth rate limit thresholds. Starting with lower rate limit quotas is helpful because they can be increased gradually instead of initially allowing a large amount of quotas and then decreasing it later due to a large number of users. Reducing rate limit values later might negatively impact the client as they become used to a certain number of requests in a certain period. We also have exponential backoff mechanism. Simultaneous requests in a time window can overburden a server, which may result in failures of requests. Therefore, to avoid the rejection of incoming requests, we can progressively increase the wait time between retries for consecutive error responses. One of the techniques used to add delays is called an exponential backoff. Another good practice is to implement exponential backoffs in our client's software development kits and provide sample code to developers on how to do that. Exponential backoffs can cause an increase in delay. Why should we still use them? At the individual level, it may cause latency, but this approach is collectively better for everyone because it decreases the request failure rate. So in summary, rate limiting helps organizations stay in control so that their service is used in a predictable way. A rate limiter not only provides a protection layer against malicious actors, but also aids in traffic management. They have a kill switch to control any runaway, or compromised accounts. In addition, rate limiters enable API developers to throttle the services provided to third-party applications, and depending on the application requirements, various rate limiting algorithms can be used. So let's do a quick quiz. Why should we avoid placing a rate limiter on the client side? So let's take a look at this. So A, it's impossible to place a rate limiter on the client side, which we know is wrong. Placing a rate limiter on the client side can tempt the clients to interfere with rate limiter to circumvent their control. That's a little bit more true. The client doesn't use the rate limiter, which is untrue. Or D, none of the above. So the answer here is B, because we don't really want to place a rate limiter on the client side because that could cause tampering on the client side, and that kind of defeats the purpose of even adding a rate limiter if they could just get past it. And which option is not the responsibility of the rate limiter? So A, we have spike arrest. B, we have traffic prioritization. C, we have traffic redirection. Or D, all of the above. And so we don't need a rate limiter to redirect traffic. So the answer here would be C. Thanks so much for watching. I know this video was a little bit rough and I've been kind of off in my YouTube schedule, but I really do want to make better content, and more than anything I want to stick to my schedule and make sure I'm, constantly improving in my technical abilities and, teaching more. And hopefully you guys learned something. If you like this video, leave a like and subscribe. If you have any questions, leave a comment, and I will see y'all in the next video next week. So peace out, guys.